In this I do problem, we are trying to figure out for the following pairs of elements. So let's say we've got sodium or lithium and then fluorine and oxygen. We want to choose the atom with the higher first ionization energy, the larger atomic radius, and the higher electronegativity. So it might be helpful to go back and kind of review the trends and the definitions for these. Uh, let's see. Let's locate these on the periodic table. So sodium is here and lithium is there. So they're both alkali metals. And then I'm going to go ahead and mark the other two, fluorine and oxygen. So those are both in period 2 and they're right next to each other. That way we kind of know what it is we're taking a look at. All right. The first thing we want to look at is ionization energy. Now, ionization energy is the energy it takes to remove an electron from an atom. So technically, the smaller an atom is, the higher the ionization energy. So the way that I guess the trend works is it increases as you go up because you're getting smaller. And it also increases as you're going left to right because atomic size or atomic radius also gets smaller. So the highest ionization energies are basically the elements that are in this upper right hand corner. So between lithium and sodium, since ionization energy is increasing as you go up because the atoms are getting smaller and the valence electrons are being held closer to the nucleus, therefore they become more difficult to remove. We would say lithium is going to have the higher ionization energy between sodium and lithium. Now, down at the other end, I'm going to kind of erase this. We can see that fluorine and oxygen, there we go. So fluorine is smaller than oxygen, and therefore it's going to have the higher ionization energy. So it's going to be lithium and fluorine. And since I just talked about that, I'm kind of answering B already. The larger atomic radius is going to then actually have a lower ionization energy because the larger the atomic radius, the further the valence electrons are away from the nucleus. So sodium is going to have the larger atomic radius. Remember, lithium, its valence electrons are in the 2s sublevel, and for sodium, the 3s sublevel. And so the valence electron in the 3s sublevel is furthest away. And so it's going to have a larger atomic radius. Also, since oxygen is larger than fluorine, its valence electrons are going to be a little bit further away. But really, the big thing with oxygen and fluorine has to do with nuclear charge. Fluorine contains more protons, and so it's going to hold its valence electrons a little bit closer to the nucleus than oxygen, which is why oxygen is slightly larger, but also its nuclear charge that really has a lot to do with ionization energy. But anyway, the larger atomic radius in that case is going to be oxygen. The last thing we're taking a look at is electronegativity. And if you go back and you take a look at electronegativity, electronegativity deals with the ability of an atom to attract electrons to itself in a bond or to attract a shared pair of electrons to itself. So for electronegativity, it is going to decrease as you move down a column or down a group, and it is going to increase as you move across. So it technically has the exact same trend that ionization energy has. The only difference is we really don't have any appreciable values for electronegativity for noble gases. So unlike ionization energy, where noble gases have the highest ionization energy within that period, we really don't have values for noble gases. Not a big deal because we're not really dealing with any noble gases here. So for sodium and lithium, the one that has the higher ionization energy, we said was lithium. Also, because it's smaller, it's going to be able to attract electrons to its nucleus and a bond better. So lithium is going to have a higher electronegativity. And Same thing. Fluorine is going to have a higher electronegativity, not only because it has a greater nuclear charge, the valence electrons are being held a little bit closer to the nucleus, but fluorine actually has the highest electronegativity value on the periodic table. So, in a tug of war over electrons, fluorine is always going to be the winner. That's it.